on. So let's talk about organic chemistry. Now, when I talk about organic chemistry, I'm not going to talk about the basics of carbon and the 4 bonds and yada, yada, yada. What am I going to talk about? I'm going to talk about how we go about naming things. Why? Because naming things is probably the most important skill, and it's become a lot more difficult as part of this sort of moving into year 12. Moving into 3-4, it becomes extensively more difficult, and it becomes extensively more like to the point and detailed, and I'm trying to think of the exact word, but you need to be precise. Like the examiners and your SAC markers are going to be nitpicky about little things, and you need to be onto it. Your attention to detail needs to be really high here. The reality is you can't get away with simple little errors like forgetting a comma or forgetting a dash. It's wrong. You need to be really nitpicky here. So let's talk about how I approach nomenclature. So nomenclature, again, fancy word for naming things. Really important. This is how I approach nomenclature. You don't necessarily have to take this approach, but this is how I approach it. And I would highly suggest this is how I've taught it to all my students over the past, 6 years, and it's sat them well. So how would I approach this? So my first step here is I'm always going to identify the longest chain. And it's really important. That's the first thing I'm going to do. I'm going to name it appropriately, meth, eth, prop, whatever it is. I'm then going to identify the homologous series. Identify the homologous series next is really important. Why? Because then it can sort of set up the rest of what you're doing. So you have your ane, your ene, or your ine. You just number off your chain, figuring out where it should be. You obviously haven't done your functional groups yet, but we'll figure that out next. Then I go through and identify my functional groups. I need to determine whether I'm going to need a prefix or a suffix. That's really going to determine how I then go and name things. I then count the carbons from the highest priority end to the lowest priority end, and I number appropriately. And then I ensure there's a few rules met. Now, I should have probably put this down here because it should really be in the rules, but we'll talk about it now. Really important. When you are writing out the name of something, if you have a number, so 2-methyl, it goes 2-methyl. Really important. Now, if I have 2 of something, so let's say I've got 2 side chains, and I've got a methyl group at the 2nd carbon, and I've got a methyl group at the 3rd carbon. And I know that I'm going to have to do dimethyl. But the 2 and the 3, there needs to be a comma between the 2. It needs to go 2, 3 dash dimethyl. Really important. Commas separate numbers. Really important. You must have commas between numbers. You can't just write 2, 3 or 2-3. That's not right. It must be 2, 3. Then you put a dash between the 3 and the word. So letters and words, dashes between them. Letters and numbers, dash between them. Numbers and numbers, commas between them. Really important. Then you need to ensure there's a few rules that are met. So you need to ensure there are no spaces in your word. The only things that accept spaces are like if you're doing a carboxylic acid, so it's an oic acid, an ester where you've got an ill OA, you're going to have gaps there. There's spaces there. That's acceptable. No other point is it acceptable. If you're doing 2-chloro, 3-bromo, 2-methyl pentane, there was like 5 words in that. You read that as like 2-chloro, 3-bromo, or 3-fluoro, 2-methyl pentane. I read that as like, there's like 7 words there, but there is to be no gaps. The dashes don't count as spaces. There must be like 2-chloro, dash, 3-fluoro, dash, 2-methyl pentane. No space between the methyl and pentane. It all has to, there must be no spaces in that entire thing. It must all be like written as one word. Duplicates of functional groups, you should know this from last year, but if you don't, if you have 2 of the same functional groups, you have 2 chlorines, you need to do di. If you have 3, you need to do tri. You're never going to have 4. I've never seen one come up in an exam or a SAC. I've seen them come up in like company ones that are trying to make themselves a bit harder than what they need to be. Never seen it come up in a VCAR paper. And then this is a rule we're going to talk about because this is a rule that lots of students sort of fail to learn or it's not taught. Multiple prefixes. If you have multiple prefixes, so you have multiple things at the front of the word. So you have chloro and you have fluoro. Really important that they are alphabetical order. So let's say that the fluoro in this case is on the first carbon and the chloro is on the third carbon. They're the same priority, so it's a bit hard to sort of discuss. But let's say that you've got fluoro on your first one, you've got chloro on your third one. It would make sense that you do 1 fluoro, 3 chloro, because it reads 1 then 3. It's actually wrong. You need to do it in alphabetical order. It has to be in alphabetical order. So it has to go chloro, then fluoro, because C comes before F in the alphabet. Now, if you've got a di or a tri on something, like you've got di-fluoro, the di doesn't count. You still go off the F. Or dichloro, you still go off the C. Dimethyl, you still go off the M. You don't count the di and the tri as part of your alphabet. Really important. But multiple prefixes must be in alphabetical order. Now you might say to me, what about multiple suffixes? You don't have multiple suffixes. There's only ever one suffix. You can only have one suffix. That's why some things have both a prefix and a suffix way of writing. The suffix is always like you want to do a suffix. The suffix is you can do a suffix, you do it. But if it's not available because you've got a carboxylic acid, so you've already got an oic acid, you must then do the prefix. And if you have multiple prefixes, because you can have multiple prefixes, they must be, when they're written out, when they're put on the page, they must be in alphabetical order. And we will discuss that. So as you can see here, don't know why that was meant to pop up second. As you can see here, first step, longest chain, you need to name down to 10. So this is a distinct change with this study design. It used to be to 8 and now it's to 10. Really doesn't change much. You just need non and dec. You should know up to oct as is. They're pretty straightforward anyway, other than meth, eth, and other than these first 4, these are all like the shapes of their like pentagon, hexagon, heptagon, octagon, nonagon, decagon. So think back to your sort of year 7, like what would be geometry and shapes. So realistically, you're just going back to there. But nonetheless, you do need to know these off the top of your head. That's reality. Bit annoying that you have to know off the top of your head, but that's what it is. Every student has gone through this exact same thing. As you can see here, here's the example of how they can be drawn out. So everything can be drawn out as a semi-structural, a skeletal, or a structural. Really important you understand the difference in that wording. Semi-structural means like this. You like write CH3, CH2, CH2, CH3. You are writing it out. You're essentially like writing it out without writing the name. Skeletal, you may not have done a lot of this in year 11. It is vital in year 12. You must know how to do skeletal. Now, really important. Why is this pent? Why is this 5? Because each corner and end point is a carbon. Unless, so if I did this here and I put an OH here, that there is ethanol. Why is that ethanol and not propanol, you might say to me? Because this is a carbon. We're happy with that. This is a carbon. It's an endpoint. This is not a carbon. Why? Because I've written something out. I've put something there. Now, if I'd just drawn this, then that's propane. Now, if I wanted to make propanol, I need to add another line and write OH. That is propane. So really important. Each of the ends are carbons unless something is written there. This, ethanol. How do I draw methane, which is just one carbon? To be honest with you, I have no idea, and I don't think you do. There's no need to use the skeletal structure of something like methane. But nonetheless, really important to understand how skeletal structures work. They just don't draw in the hydrogens. Now, what if I had chloropropane or like 2-chloropropane? Well, I would do it like this. So I have that, and then I draw another line off here, and I go Cl. So that's essentially saying that I have propane, because this is a carbon. this is a carbon, and this is the carbon, and that's my longest chain. They're all single bonds, and then I've got a chloro coming up the second one. So you do have to draw them coming off. Looks a bit weird, but that's how it works. So skeletal structure is really important. So that's the first part. Now we move on to, let's change colors. I've been using this color for ages. Let's use purple. I'm use purple. Homologous series. So the homologous series, again, pretty straightforward. You should know this stuff from year 11 or unit 1, 2. Alkanes, alkenes, and alkynes. Know your general formula. I don't think I need to talk about this too much. Then we go to functional groups. So there's a whole bunch of functional groups you need to know. You need to know all of these functional groups for year 12. Now, you need to know more about these functional groups than's on these pages. You need to know primary versus secondary versus tertiary alcohols. I think we will talk about them. I did put a slide in for them. You need to know why is a ketone in the middle? Why is an aldehyde on the end? Carboxylic acids. What do they form from? What do I do to form them? Esters, what do they form from? What do I do to form them? Remember where to break esters. Remember that this oxygen, which bonds the two, is involved with the OH, so the alcohol, and then this double bonded oxygen is involved with the carboxylic acid. So remember, it's a condensation reaction. Remember, you lose water, therefore an OH goes here, and you have a H go here. So remember, condensation reactions and where you break your esters, your amines, your amides. These in the past have distinctly been, you need to be able to observe them, but you don't need to know how to name them. They've sort of changed that. Same with ketones and aldehydes. They used to say you need to know how to observe them. You don't really need to know how to name them. That sort of changed. You do need to know how to name them now. So important that you do. These are all the different ones. Amides, we won't talk about as much today. These are part of proteins, really important. This bond here, if I change this to a carbon, if I change that to a carbon and then make that a chain here, that bond there would be called a peptide bond, and it's part of proteins. So you'll talk about this a lot more. Amides are quite important. So nonetheless, you also need to know benzenes. Benzenes are in themselves a sort of a pseudo-functional group. You don't really need to know how to name things that have benzene rings in them because it's a bit complex, but benzene rings are important and you do need to know them. They're a really special hydrocarbon. Why is that? Every single one of these has one hydrogen coming off it. Every single one. So 1, 1, 1, 1, 1. So every single one has 3 carbons coming off it. What's really important is these bonds are not stable. These bonds actually move. So notice how these are, like if I put this as bond 1, notice how bond 1 has now become a single bond and this bond has moved to the right. And then if I go back, it's moved back to the left and it's moved back to bond 1. That's because these bonds are always moving. They're in that 3, so they can never be next to each other. They always have to have a gap between them. But they're moving thousands of times a second if you've got a benzene ring. So we say that the average bond number is like 1.5 because the electrons here are delocalized, a bit like our sort of sea of delocalized electrons in our metals that we talked about last year. Essentially what's happening here is these bonds are never consistent. They're moving from one to the other. And that's why you'll find a lot of people draw a benzene ring like this, because it sort of just instigates that the bonds are always moving. You do need to specifically know this molecule. You do need to specifically know that the bonds are always moving and that it's a C6H6. It's just important that you do know this stuff. And that's how a benzene is drawn. You can draw it out with the circle. You can draw it out as one of these two. It doesn't really matter. I'm not overly phased either way. You're welcome to draw it either way. But super important, you know how to do it. Each of these points is a carbon, so you have 6 carbons in a chain. Cool. The other functional group, which is sort of like, again, a pseudo-functional group, is side chains. So alkyl groups is what we call them, but they are essentially just side chains. So if you've got a longest chain, so you've got 1, 2, 3, 4, and 5, and then all of a sudden you've got, coming off here, you've got an extra carbon. So essentially, this is your longest chain, but you've got an extra carbon here. That is an alkyl group. Now, depending on the length of this side chain is what you name it. So if the branch is 1 carbon long, it's a methyl group. If it's 2 carbons long, it's an ethyl group. Sounds a bit like a band, methyl ethyl. I'm pretty sure this is where they actually got their name. But nonetheless, methyl groups and ethyl groups are important. You do need to know how to name them. They do come up. As you can see here, this is an example, 2-methylbutane. Now, some of you may say to me, which of these is the methyl group? Is it this one or is it this one? Because essentially, I can name that as my longest chain, but I can also name that as my longest chain. If I'm being honest with you, either of them. Doesn't matter. Just pick one. Yeah, it doesn't matter. The only scenario where you will specifically pick one is if maybe there's a chlorine here. There's a chlorine here. I'm going to take this as my longest chain. I'm not going to take the other one because it's just going to simplify answering this question and naming this molecule. If I have to put a functional group on a side chain, it becomes really messy and it's not something VCE expects of you at this time. So important, if there is a functional group, I'd take that as my longest chain. If there's not, it doesn't matter. Just choose one because they've both got the exact same name. It doesn't matter which one you choose. But as you can see here, 2-methylbutane is the name because the longest chain is 4, so it's but, they're all single bonds, it's ane. My functional group is a methyl group. It's found on my second carbon because this will be my second carbon no matter what. Therefore I have 2-methylbutane, all one word with a dash between my number and my letter. Very cool. I'm very happy with that. Then we have alcohols. So alcohols, really importantly, as I said, you need to be able to name secondary, tertiary, primary, secondary, tertiary. There is far more to this. There is far more to the reactivity and what is important about these. We're not going to discuss it today. Again, we're not going to go into super detail of all these little points today. We're just going to discuss some of the basics. But really important, alcohols can be broken into primary, secondary, and tertiary. And that's a super important thing to understand. Now, why? Well, if I take this carbon, and I take this carbon, and I take this carbon. So each of these carbons are attached to the alcohol group, or the OH, the hydroxide group. This carbon has one carbon attached off it. This carbon has 2 carbons attached off it. And then, just coming back, this carbon, where is it? Has this many coming off it. So, really important. I have 3 scenarios here. I have one where I've got 1, I've got one where I've got 2, and I've got one where I've got 3. And notice the naming. I have primary, secondary, tertiary. Makes sense. Primary has 1 carbon coming off it, secondary has 2 carbons coming off it, tertiary has 3 carbons coming off it. It just makes sense. So, really important. That is how that works there. The primary and secondaries are far more reactive than the tertiaries. They become less reactive as they go up the chain, essentially. As you can see there, I make it look all nice and do it properly. So let me get rid of all this so you can see it in its nice glory of what I actually went and did before this and put some animations in and made it look nice, and then I went and drew over the top of it and ruined it. But nonetheless, all right, let's choose another color. Let's go blue. As you can see there, that's what we're doing. So what about if we have 2 functional groups? As I said before, this is where things get a little bit difficult. So when we have 2 functional groups, we need to know how to name compounds with up to 2 different functional groups. To be honest, we actually need to name things up to 3 functional groups. That's what comes up now. So how do we name something with 2 different functional groups? 2 suffixes, you can't do 2 suffixes. So as I said, you need to know your priorities. Now, this lacks your alkyl groups. Your alkyl groups fall in between here, but it's not really a big deal because alkyl groups usually try and keep them separate, but nonetheless. This is your priority table. So when you have a molecule and you need to name it and it's got multiple things, this is about numbering priority. This is not about naming priority. Remember, naming priority is all about alphabetical order. This is sort of about naming priority in terms of the highest priority will always get the suffix first. So the higher the priority on this, the more likely you are to get the suffix. However, when it comes to naming multiple prefixes, remember that is alphabetical order. Alphabetical, alphabetical, alphabetical. However, when we are numbering, so we're numbering our carbons, we are numbering according to this priority group. We are numbering accordingly from highest priority to lowest priority. Carboxylic acid has to be at the end of a molecule. We know that. It has to be at the end. If I go back, where is my... Yeah. So remember, carboxylic acid has to be at the end. Has to be all the way back here. So given that it has to be at the end, usually it just makes it easier for us chemists to give this one. And that's what we do. So we give that the highest priority. So if there is a carboxylic acid, it must be a suffix of oic acid. It takes the suffix no matter what. It therefore means it is number 1. That is always the first carbon. That is the first carbon of that no matter what. Your next priority is your alcohol. Then it's your amines, and your amides is usually about the same, and they usually sit in the same spot. This is amines here. And then we go to alkenes, alkynes, and then your halogen groups, so your chloro, fluoro, bromos, they are last. We do not care about them. They are last on the list. Yes, they make us slightly more reactive, but they don't really do a lot. So they end up last on our priority list no matter what. They are the lowest priority. That is the reason you only have prefixes for it. So bromo, fluoro, ido, chloro, you only have prefixes for them. You don't have any suffixes. Now, these two are an exception, obviously, an ane, because they're always going to be a suffix because it just works. It's just part of it. So don't worry about this like being there. Just think about the priority of it. So where you're numbering from. So these are pretty low on the priority group. So if you've got an ene bond at one end and a carboxylic acid at the other end, you're obviously going to number from the carboxylic acid end and then put the ene bond on, like it's at the end of the molecule. So really important. This is just in terms of talking about priorities. This is where this is pretty low on the list in terms of priority for numbering. And that's really about it for that. So that's a really good table. You should have a table like that in your summary book / workbook, whatever you work with. Really important to have something like this so you can always sort of come back to it and go, all right, let's just check where we're at. All right, so a couple of extra bits as we talked about. So this is a really good example of this alphabetical order. So in this case here, we've got a scenario where our longest chain is probably this one here. I'd say let's just take that as our longest chain. We have 1, 2, 3, 4, 5, 6. So we're working with hex. So I'm fine with that. They're all single bonds. So we're working with hexane. Now you can see the answers to the right, but I just want to go through this manually. So we've got hexane. Now I've got a methyl group, I've got a methyl group, and I've got an ethyl group. So let's talk about a couple of things here. So as you can see, this should be 3, by the way. Lol. I love how this, I've tried to make a really big deal, but I've somehow boogered it up. This is meant to be 3. This is meant to be, I can't believe I've somehow boogered that up. That's meant to be 3. Nonetheless. So when we've gone through and we have numbered off, I have the option of, wait, no, 1, 2, yeah, 3, 1, 2, 3. Yeah, so this needs to be 5. How have I buggered that up? I buggered up the numbering here, everyone. I do apologize. I was doing this the other day, and I think I just misread. I missed one of my carbons for some reason. That should be 5. So, really important. So, when I number off, just as an important thing, ethyl takes priority over methyl because it's bigger. So, ethyl will be at my... will take numbering priority. So ethyl here is going to be your 3 rather than being 1, 2, 3, 4 and having this as 2. It's going to be 1, 2, 3, 4, 5. I don't know why I've put 4 in there. I just forgot one of the carbons nonetheless. So what's really important about the scenario, and less so about the numbering, I'm not worried about the numbering. So I do apologize about the numbering being wrong, but you've got hexane. Now with your hexane, what's really important here is that you have 2 methyl groups and you have 1 ethyl group. So, dimethyl. Dimethyl reads di-methyl. It reads D. Ethyl reads E. A, B, C, D, E. So you would naturally think, as I said, dimethyl would go first, despite the fact it's numbered second. But it's actually wrong because we work off the methyl. We don't work off the D. We don't work off that. We work off the methyl and we work off the ethyl. E is before M in the alphabet. E therefore goes first. Ethyl, methyl, ethyl, methyl. Because the E is the higher sort of naming priority in terms of our alphabetical order. So E goes before M, therefore it needs to go ethyl, methyl. I do apologize about the numbering. Don't worry about the numbering here. Numbering doesn't influence it. I'm just talking about ethyl going before methyl. Really important. Despite the fact it's got a di there and D ends up before E, it doesn't matter. You go off the M and you go off the E. So E before M, therefore ethyl goes before methyl. So as it says there, you're going to work off the alphabet. You're going to do dimethyl. Dimethyl, the M, hence, will be placed after the ethyl because E is before M in the alphabet. If the same substituent is repeated on the same carbon, repeat the number. So as you can see there, 5, 5. Don't write 2-dimethyl, write 2,2-dimethyl, or as you can see here, 5,5-dimethyl. Really important. All right, let's answer some questions. So we're sort of halfway through organic, so we're on track, we're doing really well. Let's answer some questions. I want you to take a little bit of time. Each of these questions, what I'll do is I'll give you a couple of minutes, or like I'll tell you to pause. I want you to have a go at it. I want you to name the molecule, and then we will go through the name. So again, I want you to have a go at this. 3, 2, 1, pause. Hopefully you're back. All right. So again, remember these questions. We're going to go through our 5 steps. So longest chain, bute. So I'm comfortable with it being bute. I'm probably going to run out of room here, but nonetheless. I have single bonds, so ane. I'm not going to add the E because I know there's going to be a functional group. 2 functional groups. I've got 1. Carboxylic acid. That is always going to be highest priority, so that's going to be 1. 2, I have a alcohol. So this is going to be butanoic acid. Now, really important, you do not need to number oic acid. Why? Because it's always the highest priority. So it doesn't change. So therefore, it's always going to be in your first place. Therefore, there's no need to write 1 oic acid. Now, alcohol, that's ol. But in this case, I can't use ol because I've already got a suffix. So therefore, I need to use a prefix. I need to do hydroxy. So I need to go 2-hydroxy. I'm going to run out of room here just because I can't. This is terrible. Hydroxy, there you go. That actually was not too bad. 2-hydroxy butanoic acid. Really important. I've got the 2, I've got the dash. So my 5 steps. 1, longest chain, bute. Single bonds, ane. What are my functional groups? Oic acid and hydroxy. What is my numbering? Start here, 1, 2. 2-hydroxy. Have I done my dashes and my commas? I've done my dashes. Are there no spaces other than the oic acid? There's no spaces other than the oic acid. Have I done alphabetical order? I don't need to worry about alphabetical order. Cool. I've done my 5 steps. I'm comfortable with where I am. I think this is correct. This is correct. It's 2-hydroxybutanoic acid. All right. Let's jump on to the next one. Again, I want you to pause. 3, 2, 1. Have a go at naming this molecule. And hopefully you are back and you've had a go at this question. So again, longest chain. 1, 2, 3, 4, 5, 6. All right, I've got 6. So this is going to be hex. Oh, I need to give myself more room than that. I need to start doing it at the bottom so I give myself more room. Let's go green because this is green. Hex. All right, so I've got hex. I've got single bonds, so it's hexane. I'm not going to add the E yet, just in case. Hexane, I have 2 fluorine groups, so fluoro. These numbering priority are, there's no other functional group, so I number from the closest carbon. Therefore, it's going to be 2. So there are 2 of them. So I need to go 2, 2 dash fluoro hexane. Now, have I done everything right? I've got a dash, I've got a comma between my 2 numbers. I haven't done di. So always really good to go back and check and go, oh, have I done this correct? Well, I haven't done this correct. I missed the di. So what am I missing? I'm missing di. D, I. And then I need to write out my 2, 2 dash. So let's check it again. Have I done longest chain? Hex. Correct. Have I done ane? Correct. Have I done fluoro? Correct. Have I done difluoro because there's 2 of them? Correct. Have I done 2, 2? I have. Have I done a dash? I have. Good. I've got the correct answer here. So it's really important you reflect on your answers. Always check your answer. Now, you actually cannot see my answer because I put it under the thing. There you go. I do apologize. I don't know why I put it under there. You should be able to see that now. So down below, you've got 2 difluorohexane. So really important. 2 difluorohexane. is what you're looking for here. It's all one word, and it had 2, 2. Now, I'm going to make sure that in my next one, move that across a little bit, I'm going to make sure in my next one I don't write under the camera. Apologies, everyone. All right, let's have a go at this last one. You have a skeletal structure. Have a go. Let me know how you go. 3, 2, 1, pause, and hopefully you are back. My coffee is cold. All right. In this question here, longest chain first. So usually with these, my way of doing it is drawing out each of the carbons. So 1, 2, 3, 4, 5, 6, 7. So I'm working with hept. All right, I've got 1, 2, 3, 4, 5, 6. There is a double bond here. All right, so I'm not going to write ene yet just because I need to know functional groups and priorities. Are there any other functional groups? No. Numbering priority, what's going to be the closest end to this? So this is 1, this is 2. So it's going to be dash 2 dash ene. Is there anything else? Is there any commas? Anything else I need? No. I've got the dashes. Cool. It's all one word. Yep. Awesome. I'm happy with this. Hept 2 ene. Hopefully you can see that. It's not under the camera. It's the other way, isn't it? It's that way. That way. That way. The camera's flipped, so it makes me feel so weird. That's my right hand. It's on the left side. Nonetheless, as you can see there, everything else is as it should be. You can see your hept 2 ene. You can see the skeletal structure. You should be fine with all of this. Awesome. All right.